Hello, hello, Vicky and others. God, I love that. Yeah, okay. I need a direct chat at some point. I looked for the function. Good morning, good morning. Good morning. Vicky and everyone. Okay, awesome. Wait, yes, okay. I think my Zoom is properly updated, and I couldn't find. I'm sure it takes a lot of work, but if you direct chat, I totally want to know how to do that. Okay, because I am. Um, Not my age. Okay. So good morning, Vicky. Good morning, Vincent. Good morning, Jean. Good morning, Melanie. Good morning, Vanita. Good morning, Gabriel. Okay, and more people coming. Good to see you all. Um, okay. We should get real. Okay, good morning. Oh, more. Okay, okay. Okay. I think we can get rolling in a second again. Good morning. And Jocelyn has an avatar every day. Yeah, that's cool. I mean, I'm down with what Jocelyn's avatar says. I mean, for real. Yeah, oh, and get right. See, if that both of them could do. All right, so one of you is telling me at some point or in office hours or something how to do. All right, whatever. Maybe I shouldn't steal your. And Alfred, good morning. Okay, and good morning, Jocelyn. Love the avatar. Good morning, Hudson. Okay, awesome. So I think that's every good morning. Good morning, good morning. Okay, so we're gonna get rolling. Again. Oh, oh. No way. I even saw that and assumed it's that straightforward. No way. All right, I gotta do that. I mean, not to do, anyway. Thank you, direct chat person. And there's only one of you, so if you did a direct chat, you know who you are. Thank you. Totally appreciate it. And good morning, Alfred. All right, awesome. I love that too. Although I can't read it. Oh, does that say we love to see you smile? Oh, that's cool. Okay, we'll do it. Oh, I will do. Oh, don't tempt me. I'll do it. But not at the moment. Oh, maybe I'll do it. Well, watch this segue. Watch this here. Buckley, watch this. Maybe I'll do it a week from today for anybody who's paying attention right now, because we're not going to meet a week from today synchronously. Like I'll get back, like I'll post it in Google Classroom, blah, blah, blah. And and also that's why you're technically at, well, it's also part, you're going to catch up. All right, very quickly, like I've been promising that we're going to catch up with ourselves with the homework. We are like, there still is homework due next week, but it's not due Monday, I believe. It's due Wednesday. There's a video and a homework, and they're due at midnight Wednesday. So not only do you have some catch up time, which I hope you use to catch up, but also like, and I'll announce this again on Monday, and I'll put in Google Classroom. But like, where the reason the two homeworks are due like midnight on Wednesday is that we actually won't meet as a class Wednesday. We won't meet in real time. Again, I'll post this. We are meeting Monday, but we're not going to meet Wednesday. So you have Monday and Wednesday to try like on your own or in groups or whatever to try to catch up with the homework and watch a video instead of us meeting class um Wednesday. So that's why bottom line, I'll say this again Monday, but bottom line, the reason that in the Google Classroom there's no homework due Monday and that there's two homeworks for Wednesday, one's to watch a video and one's to do the problem set. They're both due midnight. So they're kind of like instead of class. All right. Hopefully that's clear. But the main thing is for you to catch up too. Like, and for me to catch up with you. Believe me, I don't want to start like, believe me, I know you're like, I want you always to be ahead of me, but not by too much. So wait, can you over the, very fair question. Oh, Alfred, wow, great question. And maybe that even means he's already seen with the video that so Alfred is what you see the chat. Alfred is asking, what am I asking you to submit for the video? At the moment, the way if I don't change anything at the moment, it I'm not like okay, honestly, right now the way it's posted is just and maybe if I put a point value to it, I didn't mean to. I don't think I did. I think you can tell that even though there's a deadline, i.e., I want you to have watched it at night so that we're on track with the material. I don't think I put a point value, which is an indication that, at least for that, I just mean you to watch it. And actually, it should help you do the homework the other piece that you are submitting for points. So again, like even though you're starting to get ahead of me now, and I'm asking you to do things that I haven't like explained yet, and that will always be true, and I know that. I think that video is kind of like to substitute for my explanation, and it is me. It's not like it's whatever. It's a past class video that I, I'm repurposing. So no, so good question. But as long as you ever see an assignment that's has a deadline but doesn't have point value, that means I'm just telling you to or asking you to do it. So hopefully that's clear to you, Alfred. Thank you. Great. Okay, awesome, awesome. But then sidebar or relate. Oh, and Gabriel's got it too. Oh my God. Oh my God. Wait, so the other thing, all right, I'm not gonna ask. Okay, that's awesome. Um, but whenever I have to miss a synchronized class, which does happen and will happen, whatever that generally what happens is like the night before I post a thing that's not only telling everybody that I'm missing the class, but you'll see if you look out the night before, also usually there's a point value even for the announcement. Usually I'll say something like, if you we're not meeting tomorrow, instead do blah 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 blah. And as soon as you, as long as you receive this announcement and understand that we're not meeting tomorrow, if you reply with the word yes, you get points for that. Like usually that's what I do. Just if you just say yes, so that make sure that you're not like so that you know, and I know that you know. And then often in the announcement there will be something like watch this video and write down these two things about it. And then when you do that, I give you more points. Like if I do that, so I might ask you questions about this video, but until you see that announcement, if whenever you see a video or something posted that just doesn't have points, that just means just do it. Okay. So having said that, if there's no other, and good morning, Annie. Sorry if I didn't say, I'm just saying good morning. Okay. All right. So let's keep going. So yesterday, so this board here is we're gonna okay. So yesterday you all discussed train of thought, which I appreciate, and I got your sense of what's going on in the train. So now today I'm going to talk about like why I had you discuss that and what it's about. What's the point? Oh my God, they're all good. This is too crazy. Okay. By the way, I'll even say, well, that's interesting. I'm thinking like whether that count. Definitely, you guys who are showing the crazy cartoon avatars, which I do love, definitely submit for points. I'm going to say right now, submit them in the avatar portal. Like I'll make a new portal with more. It's definitely cooler than like a still picture. I'll give it more points. I think right now, don't submit it in the actual video portal because, of course, it is. I love it, but obviously you could just. Oh no, you can't. Wait, I have to think about it. Like if you wait, really quick, if you walk away from your screen, does it keep doing like what happens? Does anyone want to test that right? Or have you already walked away from your screen 20 minutes ago? Um, go to camera and effects and press. Yeah, but she's okay. Okay. All right. You're all getting this all counts as multiplayer co-op because this is too cool for words, but okay. And I want to go to physics now, but as long as this is happening and this is like a whole new like I'm sure there's going to be faculty meetings all about this and whether it counts as. So I just want to know, like one of you, if you haven't already, if you walk away from your screen right now, does it keep going or does it like, could, or do you not want to be? I mean, obviously I could test this with my son. I mean, I could test this. No one wants to honestly. All right. So it's that straightforward to do. Holy crap. All right. Oh, did she just walk away? Did you just walk away? So just walk. All right, all right. I would love to know because if when you walk away, if you when you walk away, it goes away, then I think it counts as video. If you know what I mean, like you're making yourself vulnerable. But if it stays no matter what, then I think it keeps going. Oh, it keeps going. All right. Thank you for your honesty. Okay, but it doesn't track. Oh, interesting. Interesting. Huh. Huh. Very interesting. I mean, this is like the future is now, yo. Um. All right, so I will open up a portal for this because it's like too cool not to, but we're not going to count it as literal video because come on, right? I mean, I'm a pushover, but I'm not an idiot. By the way, that's like the motto of this class. Okay, no, very cool. Remind me to open up. Someone can like text me later to remind me to open up a portal. Seriously, please. Okay. So back to train of thought. I love it. Oh my God. All right. Of course, the other funny thing is it makes me feel like, oh wait, so he just if you, all right, sorry. It's distracting, but in a very good way, at least right now. Okay. Um, I have taught younger kids in my life, by the way, just so you know, because all these avatars are sort of making me feel like I'm teaching college physics material to like fifth graders. But don't get me started. It's not like I haven't done that. And I don't mean that you guys are fifth graders. I mean the cartoons look like fifth graders. Okay. What was the point of train of thought? What was the point? I'm asking, like, here's the point. Here's the point of why you did that. Okay, first of all, and soon there will be I encourage you to take notes on my babbling here. Eventually, it's going to land on actual material. But first of all, even though train of thought is what we call a thought experiment, even though it is hypothetical, and technically in physics, that's called a Gedanken experiment, Gedanken. It's German for thought. Thought experiments are very important in physics. Some of the great work that Einstein did were thought experiments. Like you have to know how they work and but they are meaningful. But even though that was a thought experiment, I submit to you that all of you, at least at one point, in fact, I'll ask right now, just raise your electronic hand. If at any point in your life, even for like one, minute, you experienced that level of confusion as to whether you were actually moving or not, or like for example, if you've ever been great, thank you, Hudson, I appreciate it. Thank you, Gabriel. Oh, that is cool. But thank you, Hudson. Thank you, Gabriel. Thank you, Vicky. Thank you, Gene. Thank you, Vincent. Okay, so yeah, so you know what I'm saying, right? Like, and so it's a real experience. Thank you, Vanita. Right, like, and it can be whether you're moving or not, or it could be in what direction are you moving, or right, like you could be on the highway in traffic, like sitting there and like for a long time spacing out, and then a big truck right next to you, like starts rolling backwards, moving backwards, and you think, oh my God, my foot slipped off the brake. I'm moving forwards, or like whatever. Like you could be right, or more to the point. Thank you, Melanie. Awesome. Or more specifically, like you've all been on airplanes, and you know that on an airplane is designed for you. Oh, and sorry, Hudson, is that a question? If it's a question, let it rock. But if it's not, you can put your hand down. But okay, sorry. Thank you. On an airplane, it's like designed so that you not only can be confused, you can literally be deceived for right. Like you are on an airplane for long enough that eventually you start complaining that the peanuts aren't salty enough, or you don't like the movie, or whatever. Like you're not sitting there thinking, holy crap, I'm going 5,000 miles an hour, or excuse me, 500 miles an hour at 5,000 feet above. Like you're just like, oh, when are we going to get there? Right. You can absolutely be deceived or confused or misled about whether you're moving past the clouds or the clouds are moving past you, right? Et cetera, et cetera. As long as the airplane is cruising, right? As long as you're going at a constant velocity, i.e., same speed and same direction. Whoa, now she's got it. Okay, this is wild. As long as you're going same speed, same direction, it's as though you're not going at all, right? To every piece of evidence to your body, it seems, right? And otherwise, no one would ever get, there he goes. There goes the class. This is awesome. Otherwise, you would never get in an elevator, right? Like you would be nauseated the whole time. So what is that all about? Well, even one person in this class, or someone yesterday, maybe there's even one person even pointed out, I think it was the other section, but one person even pointed out that as to these questions, are you moving or not? Like one person said, like, well, what do you even mean? I mean, the train it might be moving, but like even if the train is moving, I'm not moving compared to the train, right? So what does that question even mean? And then another person pointed out, I think in the other class, like, well, wait, like even if the train's not moving, and even if I'm sitting still in the train, like the train is attached to Earth, and like Earth is apparently moving, right? So what does the question even mean? All very fair. And here's where we're going with this. Right. Let's talk about that for a second. Like even the train supposedly is on an Earth. Well, I mean, the train is on an Earth, which supposedly itself is already and always moving. Right? We learned all that in third grade, or so, like we're on an Earth. It's going past the sun and spinning around its own axis, et cetera, et cetera. So like, wait, does that even factor into the whole question? Is Yaver round mean for us to factor in our knowledge that the Earth is always moving? Very important question. Here's where we get into physics. And I'm not saying that you were supposed to factor that in, but it's very legitimate that someone raised it. Like, wait, what about the Earth? Here's my point. Yeah, what about the Earth? My point is actually ultimately that once you remember, wait a second, I thought we were supposed to be on an Earth that's supposed to be moving all the time. Like, didn't I learn that in third grade? I say, hey, yeah, what about that? We did learn that in third grade, but like, did we learn it or did we accept it? Did we understand it or did we memorize it? Because, like, here's my point. Yeah, I was told that the Earth moves always past the sun, but I thought I was also told that science is supposed to be about observable data that is brought in from the outside world, put in my brain, and then churned around through language in my brain, especially on a long drive, right? Right, totally. So so I've been told my whole life that the earth moves, and I've been told that that is science. And I've even been told, maybe, or maybe you were told, that Galileo was a hero for rejecting the dogma of the authoritarian structures around him, that apparently Galileo was a hero for beginning the scientific method and trusting the data of his sensory observations and the results of his analytical mind. Apparently he trusted observation, like empirical data and analytical inferences over authority, over dogma, and decided it's not the case that the earth is just sitting still at the center of the universe. It can be understood or believed that the earth moves through the universe. And we learned that he's like the one of the grandfathers and grandparents of science for doing that. And doing what? Going against blind dogma and actually beginning a method of empirical observation and analytical inference so that he could know what's really going on in the universe. Like, I don't know about you, but I learned some kind of story like that about Galileo. And I learned that the punchline was that therefore we now all understand that the earth is actually moving. But here's the thing. The thing is, what? The thing is, what? Wait, evidence of the senses and analytical inferences lead me to the conclusion that the ground below me is moving all the time? Like, that's science? I don't know about you, but I mean, it is apparently science. But when I first learned and I first made my model solar system out of like a watermelon and an orange and a ping pong ball or whatever, like I did what I was told and I got the point. Okay, the earth is moving. But I'll tell you what, that was to me one of the first unconscious signals that I received that said science, they just tell you stuff and you accept it. And it's like a whole different way of thinking and you move on and you do like, that's when I started thinking that science was not about the world, because my world, the floor is stable. In my daily life, I walk around the floor like it is fixed and like I do things on it. And when I jump up, I don't expect the eastern wall of a room to slam me in the ass, or pardon my language, or I don't think that birds have a harder time flying east than west, or if you see what I'm saying with this, or if I drop a ball, I don't expect the earth to slip out from under it and the ball to land in a weird spot. Like, and I don't see the earth going past the sun. I observe the sun moving every day from east to west, just like all the Greeks, the ancient Greeks and the ancient Hebrews and the ancient Mesopotamians and the ancient Chinese, everybody. Like, we observe the sun go from here to there. We observe the stars go from here to there. We observe the planet, right? And we observe the floor, the ground, the earth beneath us to sit still. So I don't observe in any direct way any sense of any earth moving. I feel totally stable. And yet, somewhere in my childhood, and apparently somewhere in the history of human civilization, although very recently in the history of human civilization, somewhere we came to the conclusion that even though we totally don't feel it or see it or measure it in a macroscopic daily kind of way, the earth is evidently moving. And don't kid, that's what we learned. Now, am I saying that's right or wrong? I'm saying something must be going on. I'm saying what is wrong is that we were just told to accept that in third grade and accept it as science. I think that is wrong. I think it's one of many examples where people get turned off to science rather than turned on because it's such a mixed message, but whatever, that's my problem. What I do think is that if we're going to believe that the earth is moving all the time, we better have a good reason. We better make sure we understand what we mean by motion if we're going to say that something could move all the time without us feeling it at all, right? Or sensing it or measuring it at all. Now, there is a reason. This is the reason I want to get to. But what I'm really saying right now, I know it sounds like I'm just on a rant, because guess what? I'm just on a rant. No, but here's what I'm really getting at is whatever dilemmas you were going through about whether the train is moving or not, it's not just a thought experiment. It's putting you in the mindset of the dilemmas that human civilization was going through for 2,000, like literally at least 2,000 years before Galileo came up with a sort of way of resolving the cognitive dissonance of the fact that like whether the train is moving or not is really an analogy to the question of whether the earth is moving or not. Like it's not for a long time. Some people have suggested that it is, and some people have suggested that it's not. It's actually a debate, right? And it certainly was a debate once Galileo came to, I mean, he was, as you know, he was almost burned to the stake for the side of the debate that he chose. And then he chose not to do that. And he was put under house arrest for the rest of his life for real. And the only other person I know in history who's put under house arrest for the rest of his or her life was Martha Stewart. So there you go. But I'm sure there are others. I just don't know. But so it's a serious debate. It's a serious, and now I think we have resolution on it now, but what is the resolution? Like, how do we resolve that we could say this enormous planet that we're standing on and living on all the time could be moving all the time, and yet we never feel it? Let me point out before I go any further. So when you are debating the train in your mind, it's not hypothetical. It's a totally real thing. It's called your home planet. Furthermore, I'll even say, for those of you who said, I need more information or I don't know, right, just like people in the world needed more information came into you in the form of white lights going by the train. What do the white lights represent? The stars, right? We get more information about where we're standing as we study more and more deeply exactly the nature of those white lights in the sky. But we have to study them very deeply, just like you found. They enhance the question. Many of you changed your vote on the question when you saw the white light, or when you took the white lights into account. So they are data, for sure they're data. And the canopy of the stars in the sky to this day, literally, in my mind, sits as literally the oldest, most best preserved data set in the oldest, most best preserved lab that scientists have ever had. Like whatever. Oh, Annie, awesome. I'll get you in 1 second. I'll just finish this sub rant. And then just to be clear, stars are a data set. When you look into the sky, you're in a lab looking at a data set. The coolest thing about that, I mean, right? It's a scatter plot. Stars are a scatter plot. The coolest thing about and there's like approximately 1,500 of them that you could see every night without any equipment, with just your naked eye, if you don't live in New York City. And just to be clear, one of the things that's great about the stars is you're looking at a scatter plot that you know for a fact is the same scatter plot as Aristotle looked at, or Muhammad looked at, or whomever. Like it's the one time you can it's the one arena you can be in the same lab as everybody else was since the beginning of history. Like it's literally the same scatter plot. Every time I think about it, it blows my mind. So wait, okay. So the white lights in the train of thought represent the stars. Doesn't mean it doesn't answer the question immediately. People were looking at the stars for 2,000 years before Galileo, but it starts to give information. And then if you look closer at them, we get more information, which brings us to the resolution that I will say in a moment. But first, sorry, Annie, go.
Yeah, so Professor, I noticed how you called the lights stars. So I wasn't sure in the question whether they're referring like the lights as like shooting stars or stationary like street lights, something like that, because there was a question that's asking whether um you're in the train, but whether the lights are moving as well. So actually my group had a disagreement where I think Gabriel and Mariam thought they imagined the lights as like stationary, like signal lamps or like street lights. So if it flashes through the window, that means like the train is moving, but the lights are stationary. But I imagine them to be like shooting stars, where like if the train moves this way, then the lights could be like shooting this way, but you would have no way of knowing whether the lights are like also moved or they're fixed in place, but you're moving. So I said, there's not enough information, but like which type of light are you referring to?
Wait,
That's what I'm
okay. All right. Great question. Great question. And lots of points. And also, I totally see where you wrote geocentrism. Right. We are talking here about the shift from geocentrism to like heliocentrism. Absolutely. So on your question, I will answer, but I have one question about your question. I'm slightly confused about one thing. Are you saying that literally in the packet, like literally in the train of thought assignment sheets, did I literally use the word star in there? Like, and it,
No, no,
oh, oh,
no, because I think you're just like restating the concept of like you're on something that is moving and then there's another object, but you're not sure whether that's moving, but you refer to them as stars like just now. That's
oh.
why I was wondering like in the packet, which type of light are you referring to? Because a lot of objects could be illuminative, but I just wasn't sure like whether it's a moving like a shooting star or the lights are from like a street lamp.
Got it. All right. Great question. Great question. Right. Yeah, it's exactly the point. In my mind, when I say that they're like stars, when I say that those white lights of your packet represent stars, right. In my mind, I'm not thinking shooting stars as such. I'm thinking constellations, like regular stars. So that's my answer to your question. But for sure, it's still a great question because that's the thing. Like, like even constellations, regular stars, like Scorpio, Sagittarius, or the Dipper, whatever you Orion, whatever you've ever heard of, those shapes of stars that everybody has been seeing for 2,000 years, you may or might, now this is a whole other subject I could go crazy with, but and you may or may not know, but all of those shapes, like Orion, Sagittarius, Scorpio, all of those shapes are shapes, i.e., the stars are fixed in position relative to one another. The shapes never change over thousands and thousands of years. However, all of the shapes together move across the sky every night. You might or might not know this. Like if you stared at the sky, if you slept in a tent and looked at the sky like all night, you would see all, particularly the zodiac constellations, you would see them move across the sky information from east to west, just like the sun moves across the sky from east to west every day. And in fact, you may or may not have ever noticed this. You would also see the moon do that, go from east to west across. But I mean, that's a slightly different subject. But so all the stars move. And in fact, that's why people will say, like, oh, this is a winter constellation, or I'm born in November, so I'm a Scorpio, or whatever. What does that even mean? Like, why are people saying that? Because the stars are always moving across the sky. So, certain days at midnight, you'll see certain constellations, but others will be back underneath the earth and you don't see them, but they just keep marching across. So then later in a later season, you'll see the other ones. That's a quick summary. So what I'm saying is the really important thing I'm saying to get back to all this, to Annie's question and to everybody, even the white lights known as stars, they move all the time past us. They do, like visually. All stars move all the time past our vision, just like the sun moves past our vision every day. I mean, they move every night. The sun moves every day. I mean, it's all happening all the time. It's just during the day you see the sun and it's out it's so bright that it that it drowns out all the stars that are actually still there. I don't know if that's some people might not realize that, but like all of this is happening all the time, continuously. Point is, it's all moving all the time past us in the sky. So for thousands of years, it's very confusing issue. Like just like what Annie's just saying right now, like even if we don't get into like shooting stars or and similar, even if we don't get into shooting stars, we're seeing motion all the time of these white lights in the sky. So it looks like that's all going past us. But some people could say, well, wait a minute, wouldn't it look that way even if it was still and we were moving past it? Like, do we really think that all of those stars are really moving through the universe, like all together like that? Because they do, they all move together. It's called a canopy of stars, and it has shapes because it all moves together, which is very interesting. So it leads to the question, like, wait, I don't even know what's going on, even though I'm looking at them. And same thing with the train. Like the train, the white lights, the reason they're an analogy is exactly what Annie is raising. Like if I'm in a train in the middle of the night and I see a bunch of white lights rush by, it could be white lights that are fixed, like street lamps, like she said. It could be white lights that are fixed to the subway station. Like I could be going through Union Square or whatever, and there's all these white lights. And because I'm going through, I see them rush past me in a certain direction. They could be going that way, and I'm going there, or I'm going like that, and they go like that. Or I could be sitting still, and all those white lights are attached to some other train that's going past me. Like if it's truly dark enough and it's truly smooth enough and it's like Tokyo or Washington, D.C., like it can literally be confusing. And what I'm trying to say is that confusion is not you being confused, like you, Annie, or you, anybody else. I'm not saying you're like missing something. And I'm not saying that I tried to trick you in the assignment. I'm saying it's literally tricky in the universe. Like we could not resolve that for 2,000 years. So Galileo comes along and notices a bunch of things. Like he gets even close. Like already we have all this data from the stars, and by this time, before Galileo gets there, planets. I mean, and planets are a whole other fascinating discussion. But the big thing, with the big thing is that, but even with all that data, even seeing all the stars and seeing planets, we still, it's much more natural to view the Earth as at the center of the whole universe and view it as everything is going past us. Like all the stars are going past us at one speed together. The sun is going past us at a slightly different speed. The moon is going past us at a slightly different speed. And each planet apparently is going past us at a slightly different speed. And we have all this data way before Galileo. Like you got to know all this astronomy stuff, horoscope, like all this idea of Scorpios over here and this, all of that. First of all, is true. I'm not saying it's true that you should invest in the stock market tomorrow because you're a Scorpio. Like that's different. That's astrology. I can't comment on that. But I'm saying when someone says the sun is in Scorpio, that's a completely meaningful remark. That means the sun is in a particular location of the sky that has these stars in it that we call Scorpio. We could call it whatever we want, but we call whatever. All of that stuff and the phases of the moon that you draw right here on the board, the phase of the moon and the sunrise, sunset, all that stuff has been known for thousands of years. The Greeks, the Chinese, the Mesopotamia, the Aztecs, Mayans, whatever like culture you're from, the ancient version of that culture, like knew this stuff and knew when eclipses were like the phases of the moon and knew when eclipses were going to happen. And they were right. They were all correct. And we've been using this data forever, these data forever. But all their data assumed an Earth at the center of the universe that was sitting still. And they still got all this stuff totally right because that is the way the universe actually does present itself to us. But by the time we get to Galileo, he's got a little bit extra data going on. There's like enough confusion and enough like actual concern about the planets and how odd their motions are compared to the whole rest of the sky. By the time he gets to Galileo, he's looking at the planets very closely, and and he sees things more closely than anybody has before him. Like literally, he's like 10 times closer to this data set than 4 to 10 times closer to the data set than anybody has been before. And he's drawing it every night, which no one has done before, being that close. And he's drawing patterns that he sees and noticing very specific things, particularly about the moon and particularly about planets such as Venus and Jupiter. And why is he 4 times closer than anybody's ever been before? Because he has a telescope, which no one has had before. Like literally, he didn't invent it, but it was invented during his day, and he discovered it very quick. Like he adopted it. He's like Steve Jobs, like he didn't, or Bill Gates, like he didn't invent it, but he quickly started using it for looking at the sky and drawing carefully when basically no one else was doing that, or at least not as quickly as he was. So he started saying, wait, I think there's reason Um, I think there's reason to believe that we're actually moving through all of this. I think that, and he didn't make up that idea. He just had now more grounding for saying it since he was looking through a telescope and drawing things. So he started developing the idea, wait, I think all of this would make a lot more sense if we said we were moving. And let me pause for a second. If that's not a proof, I'm just saying he was conjecturing based on because he could suddenly see things such as the moons of Jupiter, which no one could see before, and he could see like the phases of Venus, which nobody could see before. So he was like, whoa. I think, wait a second, this whole thing could make a lot more sense and be a lot more simple to explain if we just decided we were moving through it rather than all of these complicated motions were moving past us. Um, totally just wait. So he started saying that. And of course, people got very upset. Like, whoa, no, dude, seriously, what? Like, I know what I was going to say. And let me say that when he starts saying, I think it actually makes a lot more sense to look at it as we are moving. Let's be clear. If you're like me, whenever I used to hear that the earth was moving, and part of my brain for a while was smart enough to go, wait, really, what? We're moving? What? But how did I resolve it in my brain since no one resolved it for me when I was in third grade or sixth grade or something? Like no one explained to me why we would possibly believe that. So I just decided in my brain so that I could move on. I decided, I guess we're moving very slowly. I mean, I guess we're just moving so steadily and so slowly that you could barely feel it and it barely makes a difference. That's a very reasonable thing to decide. Just to be clear, it's totally wrong. Like, no, if you believe Galileo's model and you believe that the earth is moving, um, then you believe that it's turning on its axis at close to 1,000 miles per hour if you're near the equator. That's like the speed of sound. Like it's going around its axis at close to the speed of sound, and then it's going around. If you believe, and I'm not telling you not to, but just be understand what it is that you've accepted if you believe that we're moving past the sun all the time, like the Galilean heliocentric modern model, then that means you believe we're going past the sun at approximately or on average 65,000 miles per hour. 65,000 miles per hour. That's not like so slow that you wouldn't notice it. That's like faster than a rocket ship needs to go in order to escape, to achieve escape velocity and reach the moon. Like no airplanes go 65,000 miles an hour. Rocket ships don't need to go. They go 45,000 miles an hour to leave the Earth. 65,000 miles an hour? We're saying that we move all the time? Like how? And that's what Galileo was telling his contemporaries in the early 17th century. Like, oh, we're actually moving all the time, guys. And they're like, I don't think so. And they're like, not crazy for saying, I don't think so. It's not just because they're jerks. And it's not because they have religion or something. Like, that's not, I mean, really, I mean, like, it's not a religious error or a religious oppression to look around you and go, really? Like, we're the crazy people? We're the ones that believe in supernatural things? You're the one that's believing that we're going 65,000 miles an hour all the time and yet not falling on our face and puking all the time. Like, who's the crazy person here? And I'm not trying to be offensive. I'm honestly, I'm trying to say that no matter what belief system you come from, I want you to understand there's a lot of right going on in this debate. Like, it's not the crazy people versus the sane people. It's geniuses versus geniuses of a total of different flavors. Um, and and when they say, why would we possibly believe you that we're going all the time at 65,000 miles an hour, this floor beneath us? What does he do? What's his point? Not to be weird, and Galileo is my hero, but also the church is my hero in a totally different way, like to be clear, and the synagogue, and I'm not being sarcastic about that at all. But but I'm mocking both of them in a way because when they say to Galileo, like, really, we're moving all the time, like, really, what's your like what? And they say, what's your evidence? But evidence meant something different back then until we and so he's starting to develop a notion of scientific evidence. So he's going to show them scientific evidence which is not the type, whatever that means, not the type of evidence we really like we're focused on before, but the type that you all respect, presumably, or I respect. So what does he do to show them scientific evidence of this crazy claim that we're moving all the time at 65,000 miles an hour? He invites them over to his apartment and says, here, look at this, and takes their head and shoves it into a can. I mean, not literally, I don't mean to be rude, but I'm saying he takes their head and puts it at one end of this device called a telescope So they look through one of this thing that they've never seen before, never used, this long tube. They put their eye on one end of the tube and then they look in. And what do they see? Like a dark circle, a dark screen, and some white lights on it, or whatever, or like four lights surrounding a big light, and the four lights are like the moons of Jupiter, and the one big light is Jupiter, or whatever. And he says, "Look, Jupiter has moons, or whatever." Which in itself, like, why does that prove anything? I mean, I could explain if I had, but if you're one of these people, or you're you, even if I say Jupiter has moons, why would that prove that we're moving? And it doesn't prove it, it just strongly suggests it. But even there, he shoves their face into a tube. They look at a black circle with five dots on it. He says, there, Jupiter has moons. And they're supposed to go, wait, what? I'm looking through a can and there's a black screen on the other end. And on the black screen, there's white dots. I don't even know if you painted those white dots on the front of the thing, or I don't even know what, like, what? Why? I'm looking at white dots on a black circle in a can in your house. What does that have to do with the structure of the universe? And that's a totally reasonable question. Like, what I'm saying is his scientific evidence was evidence that was collected through an instrument or a piece of equipment that just got invented yesterday. Why the heck would anybody regard that weird device as anything other than witchcraft? Like, and no offense, some of my best friends are witches. No, maybe not my best friends, but like, seriously, what? Why would you think that that means this? This is what's difficult about science. Like, even when we're right, like, what, right based on what? Sorry, I'm going, but you see what I'm saying? People that were debating him were not crazy. He seems crazy, even to me when I think about it now. There's no reason to trust a can until centuries later, when it's been established and reproduced many, many times, and it's in everybody's household now, and you could buy binoculars for $15 at a child's store that's more powerful than that telescope. Now we all view it as evidence, but it is not direct evidence when it's first, adopted. So what does he have to say to people? Okay, you might think, can you get to the point, Yaverbaum? Fair enough. Okay, here's the point. What he has to say to people, what he has to say is something he has to appeal to logic and reason and personal experience, just like I do to make this point to you all. Galileo has to say, and he does in a couple of books that he writes, where he also includes all these beautiful sketches of this stuff that he's seeing. He basically says, look, hold on, people. Can you imagine yourself in the basement of a boat? I mean, in the hull of a boat? Like, they didn't have airplanes then, but they had boats. So he's like, hang on. Imagine. And so he basically does train of thought, is what I'm really, my train of thought is like me made up like 21st century, like, but he does an analogy in his books that he publishes. He says to people, imagine a boat that you're in the basement of the, not the, you're in the bottom of the boat and the boat is hitched to the dock. It's docked. So you go down to the bottom of the boat and you look around at like you're the captain's office in the bottom of the boat or something, and there's like a desk and a chair. And again, this is like him. I'm paraphrasing. He didn't write in English anyway, but this is his deal. Galileo's scenario, his thought experiment. He says, look, if there's like a chair and a desk in the bottom of the boat, and there's like a fish bowl on top of the desk, and a fish is like happily, like, because they had fish then, a fish is like happily like going around in the fish bowl. You could look, and you can observe, and you could take whatever measurements you want, and you could assess the situation, and you're stable, and you could like eat your lunch happily. That's when the boat is docked. But then if they untie the tie and they let the boat go, and the boat starts cruising on the ocean at a constant velocity, even though the ocean has waves and it's not going to be a perfect boat. It's not a Tokyo subway. It's a freaking 17th century boat. But even there, he's like, he knows that his people know that once the boat is doing its thing, cruising, constant velocity, constant speed, constant direction, then you can go down into the bottom of the boat and take all the same measurements again. Look at the desk. It's going to be just as stable. Look at the fish going around the bowl. The fish won't be freaking out the way I am right now. It will be totally stable. He's like, can you really tell the difference? Whether the boat was moving or not? You wouldn't know. You wouldn't know. And he's like, so that may not prove anything, but let's get it straight right now. Maybe the earth is moving, maybe it's not. But it's not crazy for me to say that it's moving, and it's not sufficient for you to say I don't experience the evidence of Earth moving, because you wouldn't, is what Galileo says. Now, this is revolutionary, and I'm watching the clock. Believe me, we're getting now to the board. What's on the board? The thing that I have to like concretely teach you, the revolutionary moment in the writings. And Okay, we'll start writing it now. Like I think the revolutionary moment is. Whoop, whoop. Sorry. Okay. In this book, a dialogue concerning two chief world systems, which is a beautiful book where he lays this all out in the manner of a dialogue, like an argument between three people, and it's all satirical and it's a whole anyway. It's all satirical, and he has three people debating the different perspectives on this, just like you did yesterday. Like again, this is not just random. He has three people debating um, the possibility of the Earth moving or not. One represents geocentricity, like Andy said. One represents a heliocentric view, and one is right in between and is in between. And so they argue and come up with all these examples and stuff. And Galileo intentionally presents it as a dialogue this way, so that in a way to protect himself. So he's not literally coming out and saying something, although it's very clear if you read the dialogue, it's very clear like who's winning the argument if you want to see that. And it's also very clear that the character that's meant to represent the Pope and meant to represent those people who think the earth is sitting still, that character he names Simplicius, which means like simpleton. So I mean, it's clear and that's why Galileo got in trouble. But he still presents like all sides of this. And at one point, he's got this whole scenario about the boat. And he's like, come on. What if you were in this boat? Don't you see that you wouldn't be able to tell the difference either way in a boat, just like you can't tell the difference either way in the train of thought? Um, this says, my handwriting is terrible. It says, compare the situation docked versus cruising. And by cruising, I mean constant velocity. So when he says that, his conclusion, and this is now finally where his conclusion is what comes to be known as Galileo's principle of relativity. He puts this forth for the first time. Um, oh, it's always with the stuff. Galileo's principle of relativity. I mean, he doesn't call it that. We call it that in retrospect. In fact, it was Einstein who first started calling it that, like honestly, in a publication. Um, but the principle of relativity is Galileo's idea, and it's stated in many different forms throughout these books of his. He says it different ways, and we in this class are responsible for the different ways. Of course, what we're doing is English translations, but the first form, the first thing that Galileo says is he says the reason you wouldn't be able to tell the difference whether the boat was docked or undocked, the reason you can't tell whether you're moving or not on a good sleek train or in an elevator or an airplane, the reason you can't tell whether you're moving or not is that the laws of physics, whatever they are, whatever they're going to be, the laws of physics must be the same. And this is, I'm going to pause for a second. I'm looking at the time. Okay. The first thing Galileo says is the laws of physics. Physics is about motion through space and time, right? And we've just started to learn about what velocity, average velocity is displacement per time. And the word constant means the same, like holding the same, right? So Galileo was saying, whatever physics is, whatever the laws of physics are, as we understand them today, or whatever they're going to be, even the ones we haven't discovered yet, whatever the laws of space of motion through space and time must be, they can't change from one velocity to another. That's why they're laws. The laws govern velocities. They don't obey velocities. If they, that make right, just like whatever the laws of the United States have to be the same for one, or the laws of New York City have to be the same from one person to another. If one law applied to you and a different law applied to me, that's not laws. That's circumstances, right? So the laws that govern motion have to be the same laws no matter what the motion is. That almost should seem self-evident, right? Like, and no one did, and no one. It's hard to disagree with this, and that's why it's a principle. He's saying the laws are the same whether you're going. So, for example, a law of gravity. Whatever that. Now, he didn't really. I mean, he knew that gravity was this phenomenon where things fall down, and we've known that for what comes up comes down, and people have known that for thousands of years. Whether they have all the math of it worked out, whether they have all the explanations of it worked out, it doesn't matter. If not only do things fall, they fall in a straight line, right? If I'm just standing in a parking lot, I drop an object, it will fall down and land directly below wherever my hand was. It'll land at my feet, right? That's like what I understand about the law of gravity at this point. Whatever that understanding I have is, there's no way that can change and be different at some other velocity. So Galileo's saying it, so remember, and this is interesting because Galileo is like he's like the beginning of classical physics. So he begins physics not with a law, but with something before a law, with a principle. He's saying, what, just like in the United States, we have the Constitution and then we have laws. The Constitution is like the law of laws. It says how laws can or cannot be written. This principle says whatever the laws are going to be, they are not going to change. For whatever gravity is supposed to do, it's supposed to drop objects straight down. It ain't going to change whether you're going 0 miles an hour or 100 miles an hour. That's so you could already maybe begin to see, oh, is that why like it feels the same in a boat versus like a docked boat? Yes, because specifically, if you're seeing where this is going, you're correct. Specifically, let's go to form number 2. So this is all, I'm expanding now what's been on the board for 2 days. Form number 2. So this is not a different law. This is not a different principle. This is a different form of the same principle. It's a different way of saying the same thing, but it follows, and he says it in other places in the books. This is it. If you understand number 1, which I'm claiming is sort of self-evident, like it's a principle because it's like very hard to argue, even if you don't know the law. It's like if they're the laws of motion, how could they change from one motion to another if they're laws? So then form number 2 says, therefore, No experiment can be designed, well, I'll even say, can be performed nor designed to measure So this is form number two now, and I'm saying if you're following the logic of what I'm saying. So remember, Galileo is the daddy of classical physics, really classical science, classical scientific method. He is the one that brings us like, wait, we got to do reproducible, measurable observations and bring the data from those reproducible, measurable observations into our brain and then use and then apply logic and language to those reproducible, experimental results. And that will be science, right? He's the one starting that. So he believes in experiments. He's inventing the idea of an experiment while he's doing all this. And he says logically, if you really see what I'm saying, that the laws are the same, whether you're going at 0 miles an hour or 1,000 miles an hour or 65,000, as long as you're not speeding up or slowing down or turning, as long as you're maintaining a certain speed and direction. Then Galileo says, the laws are the laws, whatever they are. Therefore, so form number two, so this is like, it logically follows then, if that's the case, it has to be the case, form number two, that you can't make an experiment to find out how fast a thing is going. You cannot. Like he's literally saying, I don't even care what laws we're going to find in the future. I don't care how advanced technology. Like we didn't have a telescope 5 minutes ago. We have a telescope now. Maybe in 3 years we're going to have like freaking Zoom classes. I mean, I can't imagine that he imagined that, but whatever. Even with Zoom classes, it doesn't matter what our technology is. It doesn't matter what laws we've now unfolded or discovered. We cannot make an experiment for that would literally allow us to measure how fast a thing is going or in what direction a thing is going. Or in other words, we can't make an experiment to find out whether a thing is going or not. That's not a possibility. Why? Because any experiment we would ever do would unfold according to whatever laws there are in physics, form one, and the laws are not going to change from speed to speed. So, in other words, in the train of thought, and it's not about right or wrong answers with the train of thought, but what I'm trying to get to is that those of you who continually said, like, I don't have enough information, or it can't be resolved, or I don't know, or if you raise your hand and you ask, like, wait, which kind of stars are you talking about? Yeah, which kind of lights? Like, I need more. Yeah, you're right. I mean, I'm not saying the other people are wrong to say we are moving or not. Like you're all right to have done it the way you did it. But the fact that even with the white lights or even with more information, it still seems like we can't resolve something. The specific reason for that is form one and form two. If I were on an airplane and I woke up in the middle of the night and it was dark out and it was super slick and everything. And I woke up and I was like, wait, I don't know if I've gotten there. Like, are we stuck in the runway waiting for instructions or are we like moving over Africa? Like, and really, your body wouldn't know if you just woke up and you look out and it's dark and let's say everybody else is asleep or whatever, you literally couldn't tell for a minute. It's not that you're crazy. It's that you can't tell. And so if you decided, wait, I don't want to be crazy. I want to be really smart. I'm a scientist. I go to John Jay for heaven's sake. I'm going to be like, I'm working for the FBI next year. So I'm going to do an experiment. So you say, I'll do a simple experiment. I know what gravity's supposed to do. Gravity's supposed to drop objects straight below my hand to the floor, like in a vertical line. So you say, and I know that's what would happen if I were in a parking lot, if I were parked on the runway. So you take out your keys or whatever, and you drop it. And then it go and you're like, all right, if it lands directly below my hand, if it goes in a vertical line, then since I know that's what would happen if we were parked, then we must be parked. But what Galileo's saying is, nah, the laws would be the same even if you were going at 500 miles an hour. So even if you were going at 500 miles an hour, it would land below your feet, which is the whole reason you feel comfortable standing up and doing the experiment in the first place, and why you don't mind going to the bathroom in the middle of the flight. And if someone says, pass me the peanuts in the middle of the flight, you don't go like, here you go, 500 miles an hour, right? You're just like, right? Because the laws are the same either way. Therefore, you literally cannot do an experiment that will resolve whether you're moving in the clouds or the stars are staying still or vice versa or whatever. You cannot resolve by experiment, like ever, whether it's you moving past something else or something else is moving past you. That's not available to your senses because the laws, whatever they are all the same. Therefore, so you cannot do an experiment. This is true to this day. And this, honestly, if you've ever heard of relativity and Einstein or special relativity or the twin paradox or black holes or general, all of that stuff, which is super cool and super true and super 20th century, all that starts with this, like explicitly. Einstein begins all of that stuff by quote by referring to this and calling it Galileo's principle of relativity. Um, and then just takes it another step, but that's another discussion. But so this is real. This is where physics begins, is with this notion of relativity. And when I say this notion, now I'm going to be explicit. Form 3. So remember, these are all just different forms of the same idea. Each one is like a logical extension of the last one. Like if form 1 is true, form 2 has to be true, is what I'm claiming. And if form 2 is true, then form 3, well, and so on. And there's a bunch more forms to come. And everything we do in this course and the next course, really, but specifically this course, in one way or another, everything we do comes down to one of these forms. Each form is just our brain going another step on this idea that, wait a second, laws must be laws. If laws are laws, then you can't do an experiment to figure out if like a thing is moving. I mean, you can find out that there's motion between the plane and the clouds or between the train and the stations. Like, something is moving, but you don't know, but one thing is moving compared to another. You can't know that one thing is literally moving through space. So therefore, and you can't know that through experiment. Now, Galileo is like the first guy or among the first people who's saying, it's one thing to do all these thoughts in our head. We've been doing that for thousands of years. We make major advancements doing math, philosophy, theology, all this stuff in our head. But if now we're creating a new branch of thought and truth and knowledge called science, if from here on in we're saying, if you really want to ground your thoughts in something outside of yourself, you better start taking measurements in a way that is reproducible over and over again and controlled, not just by you, but by any colleague that you send the instruction manual to, right? Galileo, as you know, develops this method for collecting data from the outside world so that we're not just spinning our gears in here. And so that even if someone wants to challenge someone else, there's an instruction manual they can follow to see if they get the same data or not. So Galileo starts saying, from here on in, what's true in experiment, what's discoverable by experiment is true and meaningful in this new thing called science or physics. And what's not discoverable or verifiable through experiment is not meaningful in physics anyway. Like maybe it's meaningful somewhere else philosophically. But from now on, if it's going to be meaningful in physics, that means it ties back to data taken from controlled experiments. Therefore, Form 3 says, well, since you can't do an experiment to figure out how the velocity of a thing, then therefore, I guess, Here, let me write. Sorry, let me write this different. Sorry. Hold on. Same idea, but okay. So, um, here's form three. Form three says, all right, it's meaningless. It's literally like meaningless. It's out. It doesn't mean anything in physics at all to talk about the velocity or to measure or to consider measuring the velocity of a single object because you actually can't, is what Form 2 is saying. Like you can't design an experiment to measure the velocity of a single object. You can measure the velocity of an object relative to another. And that's what's going on in the whole train of thought thing and the whole like, or you can say we are when you see the white lights going past you, you can get a ruler and a stopwatch and whatever and say, okay, those white lights are going past me at 3 miles an hour. Like every hour they move like 3 miles, scale the window up, whatever. You could say every hour it's clear that those stars are going past me 3 miles. And then and you could be right about that. And then your friend go, wait, but how do you know whether the stars are going past us at 3 miles an hour or whether we're going past the stars at 3 miles an hour? And what you do know is that the number is three. But what you don't know is whether you or your friend is right. And what Galileo is saying is right. You don't like it. You literally can't do an experiment to resolve whether you're sitting and the stars are going three or the stars are sitting and you're going three. Or for that matter, honestly, you don't know. You could be going one and the stars are going two or negative, however the numbers work. And that you literally cannot resolve. You can know the speed of one thing and the direction of one thing compared to another, but you can't know the speed and direction of a thing unto itself. You can't figure that out in an experiment. Therefore, Galileo says, therefore, from here on in terms of doing physics, we're not only from here on in within physics, but from here on in, we're going to build physics around this idea like whatever we future, not only does this apply to any future laws or technology that might get developed in physics, but what we're saying is all future laws and technology in physics will in fact stem, and they still do to this day, stem from this understanding that when we from here on in talk about motion, specifically when we talk about velocity from here on in, we're not talking about a quality that a thing can have. We're not. Because even if you could imagine that in your head, you can't get that from the natural world of data. And that's what science is about. So from here on in, what velocity is and only is a comparison, a relation between two objects, not a property one. Like literally, and you could tell I'm like screaming and everything, not because I'm angry. I mean, I'm excited, but this is like so like literally everything in physics, one way or another it does stem from this understanding of so like last week and the following week like we're going to get back to all the math of like average velocity and instantaneous velocity and the equations of average acceleration and all that but you got to know and it's going to affect the so we're going to go sort of back and forth for a little while when we go back to that you're going to think for a couple minutes like why did he so okay that was really interesting Abraham I'm glad you almost like broke an artery like talking about it but like now we're back to math again like what I'm telling you two things one well, I'm telling you, the main thing I'm telling you is that all this conceptual stuff that I'm doing right now, the reasons it's super important is, believe me, it actually does affect all the equations to come. It does. And when in doubt, when you're solving problems that look more and more mathematical, you will see more and more that the issue in physics is not actually the math. You're fine. Even those of you who think you're not fine on the math, you're going to be fine on the math. The math for many of you is going to be like the crutch that you rely on. The computations are not the hard part in physics problems is knowing how to start them. Some of you may have already discovered that in homework 3 or homework 4. The hard part of physics is not turning the algebraic or the trigonometric or the calculus crank. The hard part is knowing how to set them up to know what algebra to do or what trigonometry to do or whatever. The hard part of physics problems is starting them and setting them up. That's where step 1, step 2, and step 3 come into play for real of the 5-step method. And I'm telling you that what separates people that really know how to do physics from people who just know how to do math or, just know how to do computations is that physicists, when they're setting up problems about motion, always first, their big GDP that's always in their mind, the big granddaddy of all GDPs is this idea right here that velocity is not a property of one thing. It is a relation between two things always, which conversely means from here on in, if I ever say, like, what's the velocity of bleh? Your response is to say, compared to what? Or relative to what? Now, if sometimes we'll forget, sometimes we get so caught up in the lab or on planet Earth, sometimes we're doing so many measurements in the lab that when we're measuring velocities of things, we start to take for granted we mean compared to the lab. So after a while, we might stop saying it. After a while, we might adopt the laboratory as our frame of reference or the earth as our frame of reference. But so we could get careless sometimes. But the fact is, but we shouldn't. And even when we are getting careless about naming our frame of reference, what this is saying is there always is one. And knowing which one it is makes all the difference in all the numbers and all the setups of the calculation. Velocity is relative. Velocity is a comparison between two objects. So I'm going to say, so there's going to be more forms. That's not the last form. There's going to be more that will dictate, and they're going to look more and more mathematical. And they're going to dictate, like each next chapter we do, I promise you, each next topic we do, we'll come back to one of these forms. But we're not going to do any more forms today. But I'm just going to summarize one implication of this form 3. Um, so this is all according to Galileo's principle of relativity. That's what. So if you're wondering, did we learn anything today or the last day? What you're learning is Galileo's principle of relativity that comes from like 1635. And it basically, in short, Galileo's principle of relativity is the reason we possibly could believe that the Earth is moving all the time at 65,000 miles an hour, even though we don't feel it. Like on the one hand, Galileo's principle of relativity. If you ever ask, or you ever ask your third grade teacher, or someone, or you have a third grade child or a third grade sibling, and they ever come home and they're like, "Wait, why?" And good for them if they do. If they're like, "Wait, why do we believe that the Earth is moving?" Like the fundamental, or why don't we feel it if the Earth is moving? The fundamental reason is Galileo's principle of relativity, which says that velocity is a relation, not a property. So the real answer is I'm right now stationary relative to the Earth, and the Earth is stationary relative to itself, but the Earth is moving 65,000 miles an hour relative to the sun, yet you can just as easily say the sun is going 65,000 miles an hour relative to the Earth. Either one, velocity is relative. It matters what frame of reference you choose. And so in short, what I'm saying is that it's not a surprise that we don't feel it. Because what I'm saying is because the laws are the same, whether you're on a moving Earth or stationary Earth. Velocity is a relation in order to measure, and I know we have 2 minutes. This is the last thing I'm writing, or specify a velocity. We must always first choose. Oh, weird pen, but okay. I'm looking at the time. We have 1 minute. Okay. I want to, sorry to end like this, but in all bottom line, if ever you're going to specify a velocity, you have to compare it to something. The thing that you compare it to, so the velocity of one object has to be compared to the velocity of another object. The second object, the one that you choose as your basis of comparison, the one you say, this one I'm calling stationary, and I'm comparing velocities to it, that's called a reference frame or a frame of reference. And to wrap this all around, what we're saying as Galileo is that as long as your reference frame is unaccelerated, as long as it's cruising at constant velocity, then the laws apply to it as much as any other. So all unaccelerated reference frames are equally valid, and velocity is therefore relative. Okay, I went over a minute. Sorry, I'm here if you want to ask quick questions, but other than that, keep on keeping on, and thank you for your attention.